now we have made reference to climate change without actually analysing the impact that climate change is having on cities. What are the strategies that will allow for the successful adaptation to these profound changes? How do you maintain the livability of cities in the face of these climate change impacts? Professor Nigel Tapper from the School of Earth, Atmosphere and Environment at Monash University has been studying this question for some years.
In this presentation, I want to explain to you why urban areas are so critical for adaptation to climate change, and also why water-sensitive cities are a very important part of this adaptation. I want to begin with what I think are the 5 key messages in relation to cities and climate change. The first thing to note is that globally, the process of urbanisation continues at an extraordinary rate. In 2007, for the first time in Earth's history, there were more than 50% of people living in cities. The other thing to remember also is that cities are an increasingly important part of the global economy. And by 2020, the largest 600 cities around the world will generate more than 65% of the global economic growth. The second key message is that this urbanisation corresponds with a broadening acceptance of the reality of climate change. And if we have a look at the climate records, we see indeed that there has been a dramatic shift in global average temperatures of around about 1 degree centigrade across the planet. And that's pretty much universal across the planet. Some areas have warmed faster than others, but that has been the general case. The other thing to note that's really important in the context of people living in cities is that extremes appear to have shifted more than the averages. So while we're not only getting higher temperatures, we're also getting a shift toward more extremes. That's partly because there's increased variability of climate, but there's also a changed symmetry in the distribution. We talk about this more elsewhere. The other thing to note in relation to these extremes is that there are a range of variables that are critically important in cities. And some of our research activity in the last few years has demonstrated, as we can see in this diagram, that across Australia there is a historical trend, and the projections are for example, much more warm nights, for a much greater heat duration index. So in other words, the heat wave is going to last longer. That there are going to be more precipitation, heavy precipitation days. And at the same time, there'll be more consecutive dry days. So at the same time that it's getting warmer, we're going to have more extreme hot weather, but we're also going to have greater drought, but when it does rain, those rainfall events are going to be extremely intense. And of course, these are all of critical concern to city dwellers. The third thing to note is that cities and urban areas are actually hotter than the surrounding rural environment, and this urban warmth is superimposed upon this greenhouse gas-induced climate change. That makes cities a particularly important place within which we can address climate change and adapt to climate change. These diagrams just give an indication of a cross-section of Melbourne, Australia's temperatures. You can see at night around about a 4 degree centigrade difference across the city as you move from rural through the central part of the city to rural again. And the other image is showing the plan view of the same sort of temperature distribution. It's important to note that this is really a universal phenomenon. Urban warmth is a characteristic all around the world. And this diagram shows that as the population increases across cities, no matter whether it's in Europe, in Asia, in Australia, the urban heat island increases. So urban warmth is a function of urban population density, but also this diagram shows that the rate of increase with population depends on the nature of that urban landscape. So in North American cities, the rate of increase of urban warmth with population is greater, and that's because of the high-rise nature of North American cities. The causes of urban warmth. The nature of surface materials is important. The shape and structure of surface materials is important. There are alterations in urban air quality that change the radiation transfers in cities that are important. The presence of heat sources such as cars and air conditioning and so on, that's important. But a particularly important cause of urban warmth is the fact that they are waterproof, roofs, sealed areas, roads and so on, and that surface waterproofing and the removal of storm water removes any water, a lot of the water that would otherwise be available for evaporation. This schematic shows what happens to heating above urban and rural surfaces. Sensible heating is actually air being warmed from below, so increasing the air temperature. And what we find in urban areas is that sensible heat exceeds that in rural areas. So that contributes quite strongly to the heating over urban environments. On the other hand, latent heat relates to the evaporation. And so what this tells us is that over rural environments, the air tends to be moister and cooler. So the contrast is between a warm, dry urban environment and a cool or moist rural environment. The fourth key message is that cities and urban areas are especially vulnerable in the face of climate change. And this is particularly in relation to heat, water scarcity and sea level rise. This map shows global cities and their location in relation to current climate-related hazards. The climate-related hazards we're looking at here are things like sea level rise, drought, flooding, landslides and so on. What we find is that most of the major cities around the world are actually located in areas that are climatically vulnerable. Another major issue for developed countries, including Australia, is that they have a dramatically ageing population. And this diagram shows that, for example, the population aged 65 plus is growing very rapidly as we move into the 21st century. Then the reason for this to be a concern is that older people are much more susceptible to climate change and in particular to heat that I'll be talking about in the next session. The final key message in relation to cities and climate change is that although highly vulnerable, cities do provide us with unique opportunities for adaptation to climate change. And the only thing we need to realise is that those strategies are required immediately. So if we think about some of the advantages that cities provide, we have people that are concentrated in one place, maximising opportunities for mitigation and adaptation. Cities, we know, are more efficient in terms of their lack of production, if you like, of greenhouse gas emissions. So the emissions are lower per capita in cities. Thirdly, there are many co-benefits of approaches to climate mitigation and adaptation in cities, including water-sensitive urban design. And these well-established measures to reduce urban warmth can provide headroom against unavoidable climate change. Just looking at this diagram, we can see on the left-hand side there are a range of things that we can do in cities to mitigate climate change. On the right-hand side, there are things we can do to adapt to climate change. And in the middle, there are a number of things that actually contribute to both mitigation and adaptation. And if you have a look at them, things like green roofs, permeable pavements, tree canopy and so on, these are all features associated with water-sensitive urban design. So just to conclude, these are the 5 key messages in relation to cities and climate change. And these are of critical concern for urban dwellers, both in Australia and around the world, and for all of those of us who manage, plan, design and build our cities. Let's consider some solutions in the next presentation.